Hello, my name is Chris Johannesson, and I have just entered my contact info in the chat. This is not intended as a training session, but an overview of new technologies in the version 7.0 SDK and apps scheduled for release early next week. For these kickoff workshops, participants are muted. So as we go through the material, make a note of your questions and any topics you want more info on. Afterwards, send me a note and we will try to arrange future Zoom sessions for all teams with common interests. Then we can take the time to discuss your questions in detail. Here are 5 key technologies that are introduced or expanded with the new 7.0 SDK. I will describe each of these in some detail. External libraries, advanced gamepads, Vuforia Navigation, machine learning, and the Driver Hub. After that, I will briefly cover a list of numerous additional improvements in performance and user interface. So let's get started. External libraries are publicly available code that you might want to use in your robot programming. Libraries are available at websites or repositories called repos, and can easily be found using a Google search. FTC teams who program in Android Studio have always been able to incorporate external libraries into their own code. Now, with the 7.0 SDK, this feature is available to teams programming in on-bot Java and blocks. I should note that this is available for Android 7 and higher, which means that the Moto G 2nd Gen and Moto G 3rd Gen phones cannot use this feature if they are being used as the robot controller device. Those 2 phones run Android 6. It's a simple process with 3 basic steps, and I have a slide for each of these. Step 1, find a library that you want to use and get its jar or AAR file. Step 2, upload that file in on-bot Java. Step 3 has 3 variations depending on how you plan to use the library. Step 3A assumes that you want to use the library method directly in on-bot Java. Namely, you are not planning to make that function available for blocks users. Step 3B assumes that you do want to provide the library function to a blocks user by creating a special block called a MyBlock. MyBlocks are not new with 7.0, but now you can use library code in that MyBlock. You can customize the MyBlock or not, depending on what the library method can do compared to what you want the MyBlock to do. Step 3 is a special case where you want to make the library method directly available to the blocks user without even creating a MyBlock. This can be done if the library is specially annotated. So now we will dig a little deeper into each of these 3 steps. There are hundreds, thousands of code libraries available on the internet. In step 1, you find a library with methods that you want to use. Hopefully, that repo has a well-documented interface. Review its documentation, learn what the methods can do, and learn about the inputs required and the outputs provided. If that's something that you want to use, then try to find the jar file or the AAR file. Jar is Java Archive, and AAR is a very similar format called Android Archive. This is a compressed file containing the entire collection of code that you want in a single file. It's similar to a zip file. If you're having trouble locating that jar file, or if you're not sure about how to use that library, I encourage you to contact the repo owner or developer. They usually love to hear from users and learn how you plan to use their code and would typically be happy to help you get started. Don't be intimidated. They are often quite willing to help. Then just download that jar file to local storage, such as to your laptop or to a team Google Drive. In step 2, you copy the jar or AAR file to the laptop where you are doing your programming, if the file is not stored there already. Open OnBot Java, which means that your laptop is already connected by Wi-Fi to the robot controller device that is running the 7.0 FTC app. In OnBot Java, click the upload icon, which is shown here in this slide with the up arrow. It's the icon in the middle. Normally, you use this icon to upload a regular Java file, which is stored in the team code folder. But here you select the jar or AAR library file to upload. OnBot Java will recognize that it's not a Java file, it is an archive file, and will automatically create a folder called external libraries. Again, you can see this on the screen. There's a folder that contains 3 archive files from libraries. At that point, you are ready to begin your programming, which I will cover in step 3. As part of the programming, you will import the class that is contained in the library. You know the class name because you read about it in the library documentation. Remember, when all your programming is finished, you will need to click the Build Everything icon. That's the round image with a wrench at the right-hand side of this slide. So let's move on to the programming step. The programming step has several variations depending on how you're planning to use the external library code. Step 3A assumes that you want to use the library method only in your Java op mode and not provide it to blocks users. Or perhaps your team doesn't work with blocks at all. So you can just start programming. You already imported the class, and you also know the method names because you read about them in the documentation, and you know about the inputs and outputs. If you do want to make the library feature available to blocks users, you can use step 3B or 3C. In 3B, you create a MyBlock, which can modify the library method or not. Unmodified means that your MyBlock simply calls the library method using the same inputs and providing the same outputs. This might be called a wrapper method. Or your MyBlock can use the library method as a utility function, performing a specific task in your larger MyBlock method. In other words, your MyBlock supplements what the library method can do. On the other hand, the library method might have more parameters than your blocks user needs, and so you want a simpler interface. It all depends on the functionality you want to provide to your blocks programmer. As a reminder, creating a MyBlock requires only the 2 items shown here as bullet points. Your existing op mode class should be extended, and this annotation, export to blocks, is placed immediately before each MyBlock method. If you need to brush up on that, there is a MyBlocks tutorial here. I will paste the link in the chat, or you can review this slide later when it's all posted at the SoCal FTC Discord. The third variation is step 3C, where you simply want to provide the library methods directly to the blocks user without even creating a MyBlock. You would need to ask the library developer to add 2 FTC annotations and then provide you a fresh jar or AAR file. The annotations are shown here as bullet points. If they can give you that file with annotations, all you need to do is upload it in on Java and click Build Everything. That's it. The blocks user will now see those methods appear as purple or green blocks in the menu. Pretty cool. I want to digress slightly to point out some benefits of this external libraries feature. Obviously, it provides advanced functions previously available only to Android Studio teams. Secondly, more of your team members can continue programming the robot in blocks, while other students, if they want to, can advance their Java skills and still contribute to the team's actual robot programming. So often I see teams where one student has moved far ahead with their Java skills and becomes the team programmer, the only programmer, and nobody else has the chance to learn and contribute basic programming. I think of this new possible arrangement as nobody is left out and nobody is held back. As a third benefit, judges love to hear about outreach. For example, you could develop useful blocks for beginner teams, or you could share ideas and tips with other advanced teams who are doing the same kind of development. Thirdly, I encourage you to communicate with library developers. This is a good opportunity for real-world interaction with specialists, sharing your needs and receiving expert guidance. Scientists, engineers, doctors, entrepreneurs, nobody needs to reinvent the wheel. Professional life is built on these interactions. This slide shows some technical details that might apply to very advanced use of the external libraries feature. The vast majority of teams will not need to refer to these items. They do appear in the README document at the FTC GitHub repo, or you can refer to this slide later when it's all posted online. Are you ready to rumble? Besides the Logitech F310, other FTC gamepads have rumble and LED features that are now available with the new 7.0 SDK. They are the Xbox 360, the wired version of the Sony DualShock 4, developed for the PlayStation 4, and an inexpensive clone of the Sony DS4 branded as ETPark. It's available from REV Robotics and possibly other sources. Next, the Driver Station app now provides auto recovery. A gamepad disconnect can cost you time and frustration while you figure out what happened and frantically press Start A and Start B. This new feature automatically reconnects each gamepad to its previous position, so fast you might not even notice. Also, you can now declare a default position for a physical gamepad. Some of you have that certain team member who declares that this gamepad can only be used for driving or only be used for the intake and the shooter. Perhaps it's considered more accurate, or it's their lucky gamepad, or it's covered with tape markings for certain functions. You can now specify that gamepad is in fact always user 1 or always user 2. The back and guide buttons, which previously were off limits, are now available to you to program. So the new SDK gives you 2 free buttons on all gamepad types, including the Logitech. Lastly, you can access feedback from the Sony DS4 touchpad, which is quite a unique feature. Let's talk about these in more detail. The settings menu of the Driver Station app has a new entry called Advanced Gamepad Features, which opens the screen shown here. The toggle at the top left is on by default. As the blurb says, this enables auto recovery, rumble, and LED control. If you are having any gamepad troubles, simply turn this off and you will return to the exact same control that you had in all previous seasons. In other words, you will revert to Android's native gamepad interface. The next toggle is Rumble on Bind. When you enter Start A, the gamepad will rumble briefly one time. Brr. When you enter Start B, it will rumble twice. Brr, brr. If you find that annoying, simply turn off this feature. At the right-hand side of the screen is default gamepads. If you touch this rectangle user 1, then press any button on that gamepad, now its default will be set after restarting the DS app. That gamepad's unique serial number will appear in the gray rectangle. A long press will clear the selection. If you want to temporarily override this default setting, simply choose Start A or Start B as normal, and that will be in effect for the remainder of that app session. After a restart of the DS app, the default selection will take priority again. Here are some additional details about the advanced gamepad capabilities. The Xbox 360 has 4 numbered LEDs in a ring. LED 1 or 2 indicates the selected position, user 1 or user 2. The Sony DS4, shown here in this slide, has a single full-color LED bar across the top. Position 1 is blue and position 2 is red. Rumble commands are available in blocks and Java. For Java users, there is a sample op mode listed here. This first bullet point gives a method to run both Rumble motors at full power for time. Next is an overloaded method with 3 inputs: motor 1 power, motor 2 power, and time. Motor 1 generates large vibrations and motor 2 generates small vibrations. The third bullet point shows a method that will run a custom sequence of rumbles that you design and give it a name. This method calls that sequence by name. It's a very fun feature. Each of these methods, the call initiates the rumbling. The op mode will not wait for the rumbling to end. It will proceed immediately to the next line of code. This fourth bullet point lists 3 more methods: a number of rumble blips, a Boolean to determine whether a rumble is happening, and a method to stop a rumble. Next, the Sony DS4 has a touchpad, which is the dark rectangle shown in the image. It can accommodate up to 2 fingers, and there is a sample op mode for Java users. These first 2 variables capture the X and Y coordinates of finger 1. And the third variable is a Boolean to indicate whether finger 1 is currently touching. Finger 2 has the same 3 variables available. I look forward to seeing how teams will use this feature in FTC. A tutorial was posted yesterday on YouTube by Mr. Phil Malone showing how to program these rumble and touchpad features. You can search YouTube for Gears Inc. The inexpensive ETPark clone has some limitations. It cannot do a full dual auto recovery because they lack a unique serial number. And the ETParks react differently to some rumble commands. Vuforia technology continues to be a part of First Tech Challenge. There are 4 navigation targets on the field perimeter, as you saw in the game video. These Freight Frenzy images are preloaded in the 7.0 SDK, along with the usual sample op modes in blocks and Java. These samples give you the robot's location on the field using the official FTC field coordinate system. The first sample op mode, Concept Vuforia Navigation, uses the RC phone camera. A very similar sample op mode uses a webcam connected to the RC phone or to the control hub. And there's a third sample op mode that allows 2 webcams on the robot. The sample shows how to switch between them while the robot is running. These samples just show you how to access the robot's location. It's up to you to use that information for the robot to navigate on the field. There's a new sample op mode in the 7.0 SDK called Drive to Target. This is quite different as it uses the position of the target relative to the robot. This is not the same as the navigation op modes, which give you the robot location in the global coordinate system. Currently, this new program is available as a Java sample, and a MyBlock could provide this functionality to Blocks users. In this new sample, you manually drive the robot to aim at any of these targets. Press one button on the gamepad, and the robot will drive towards that target and stop at your desired distance away from the target. A fun activity is to move the target while the robot is approaching. Again, note the difference between a local frame of reference and a global frame of reference. Speaking of reference frames, this slide shows the official FTC coordinate system as it applies to the Freight Frenzy game. The origin is at the center of the field. The yellow arrow indicates the x-axis positive direction from 0. The green arrow shows the y-axis positive direction starting from 0. The z-axis points upward, but this is less useful for navigation. Most FTC robots do not become airborne. For navigation, we care more about the rotation about the z-axis, called heading. It's sometimes referred to as z-angle, or here, z-rotation. As shown by the purple arrow, heading starts at 0 degrees when pointing along the positive x-axis. Following the traditional right-hand rule, heading increases with rotation to the left towards the y-axis. The sample op modes provide heading up to positive 180 degrees and in the other direction to negative 180 degrees. You can easily convert those values to a 360-degree system if you prefer. At each target image, the first 2 numbers are the X and Y positions of the center of the image. The units are inches. The third number is the Z angle or heading in degrees. I encourage teams to experiment with the sample op modes and try to use Vuforia Navigation in your competition op modes. Autonomous, certainly, and perhaps even teleop. Evaluate this against many other ways to determine your location on the field. This is a valuable learning exercise, even if you end up choosing another navigation method. For the past 4 years, FTC has offered a progression of technologies from Vuforia viewmarks and image recognition to detection of 3-dimensional objects using provided TensorFlow models. TensorFlow is a free open source library for machine learning and artificial intelligence. The new 7.0 SDK contains a pre-trained TensorFlow model for Freight Frenzy scoring elements. The SDK also contains the usual sample op modes for blocks and Java, updated for the current objects. Teams can perform their own training with Freight Frenzy objects or your team shipping element. The TSE is a custom object and optional scoring element that you saw in the game video. The result of training is a TensorFlow model called a tflight file, which could be uploaded to the RC device at the Manage page and accessed by your op mode. One of the sample op modes shows how to use a custom model. The REV Driver Hub is an exciting new product this year. It's an FTC appliance running a version of Android 10. The 7.0 SDK is optimized to support this device and vice versa. Early next week, look for an update to the Driver Hub operating system. The new OS level is expected to be 1.1.0. The best way to update any of your FTC devices is with the REV hardware client, a piece of software that you install on your laptop. Many of you are most excited about the full-size USB-A connectors for your gamepads. No more USB hub, adapter, and those tiny USB micro connectors. The USB-C cable is used for data and charging. The unit comes with a cable. The battery is removable and there's a speaker at the back. In past years, many teams created a driver station carrier, which was a platform or tray to hold the DS phone, USB hub, and gamepads. With this driver hub, there's less of a need for a carrier, but it is still allowed in this year's game manual. There are many improvements in the new SDK, more than we have time to cover here. You may notice that device pairing is much more reliable than before. The Manage page has been improved for better control of Wi-Fi channels and Wi-Fi bands, namely 2.4 gigahertz versus 5 gigahertz. The DS phone shows ping times. These are more accurate now. I've already mentioned the REV hardware client. It's not part of the SDK, but this year you should make it part of your team's standard operations. The FTC apps provide many levels of warnings with and without audio. These have been expanded and clarified, and in some cases muted for less distraction. OnBot Java has improved file management, including uploading, deleting, file naming, etc. Self-inspect screens have been overhauled, which I will show you in the next slide. And of course, many software bugs have been fixed. Bugs are often discovered by students, and you are encouraged to report problems and provide all the supporting detail that you have. The self-inspect screens have a new look, providing more and more useful information. Besides the streamlined pass-fail indicators, the one-word note tries to indicate the actual status of that requirement. In the past, these screens might have only a red check mark or a green X, which had specific meanings that were not always obvious. The requirements listed on the screen can adapt to the specific RC or DS device that you are using. It's important that your team stays up to date on the actual game manual rules and their amendments. These self-inspect screens are not the authority, but can help you prepare for tournament requirements. Some of you were less active with FTC last year due to the COVID shutdown, so you might not be familiar with some very useful improvements from SDK 6.0, 6.1, and 6.2. Here are some highlights. you can pre-select the teleop op mode, which will run immediately after the autonomous op mode. And you can do this right on the DS phone. This is very handy for those stressful moments between auto and teleop. TensorFlow offers digital zoom. The sample op modes have this in place with a default zoom setting, which will be quite obvious when you run them. You should experiment with this for best performance on your robot and for your strategy. Webcam controls are available. Gain or ISO, which controls the lightness and darkness of the image. Virtual pan, tilt, and zoom. This is not a physical movement of the webcam, but rather movement of a frame within the overall image captured by the webcam. And lastly, you can enable auto exposure priority. Custom blocks or My Blocks we have already discussed. This is an extremely valuable feature for teams. Driver station telemetry can now be formatted in classic, monospace, or even some limited HTML formatting. This may help you with displaying test data as you develop the robot in your team workshop. You can also make your telemetry more readable and thus more useful to your driver team, especially the coach player who might be monitoring telemetry. Switchable webcams, we have already mentioned. The driver station has a landscape mode in a very attractive format with a practice timer. This timer allows your driver team to easily practice under real competition conditions. You won't need another teammate running a stopwatch. OnBot Java has a tabbed editor, so you can have multiple Java files open in the workspace, each with its own tab. Driver station audio telemetry. This is similar to the text-to-speech feature, which was available first on the RC phone. Now the audio can play on the driver station phone. Have the robot tell you what's happening. That's all we have time for. I hope you enjoy exploring the new 7.0 SDK and apps planned for release early next week. If you have questions or would like to explore one or more specific topics, send me a detailed note at this email address or at the SoCal FTC Discord. I'm listed there as Westside. If there's enough need, we can try to arrange future Zoom sessions for all teams with a common interest. Then we can take the time to discuss your questions in detail. Best of luck in this exciting new season of Freight Frenzy.